Level 7. Gonna make something else negative now. Made variables negative last time. Today we're gonna make coefficients negative. So you know the drill. Make this your next title. Mark that page, close it up, and this is a biggie on the draw strategy. So bring maximum brain power when you unpause so that this makes it through. So like I said, last time we dealt with negative variables. So we solved equations like this. And if I just do one strategy here to speed this up, maybe do the drawing strategy, 4n plus 13 equals 9. We took 13 off of both sides, took away that constant, and then we figured out that that would make the variable, in some cases, have to be a negative number. So last time we dealt with what happens if the variable is negative. Today we're going to deal with what happens if the coefficient is negative. And to remind you what that is, in an equation like this is the variable, of course, the unknown value. This is called the constant. Talked about that a lot in the last lesson. This one is called the coefficient. It's how many x's or y's or variables do you have. So what today happens if that is a negative number? Let's see. So I'm going to do two I do's. I'm going to do one where the variable ends up positive, where so here x is going to end up positive, and then the next one I'm going to show you what it looks like if x ends up negative, because something weird happens. It's a big new step, especially in the drawing strategy. So common sense, already starting to get really, really tough. Look at that, negative 3x plus 40 equals 16. I can't just jump to a conclusion and figure that out personally. So visual strategy also seems weird. How in the world do I draw negative 3 of the x's? How do I draw a negative number of it? Here's how. I'm going to draw 3 opposite of x's. So rather than thinking that as a negative sign, I'm going to think of it as an opposite sign. So I'm going to have whatever x is, the opposite of it. So this sign means if x was negative, this is positive, or vice versa. If x is positive, this is negative. So I'm going to draw it like that. I'm going to draw 3 opposite of x's to represent that, and then the rest as usual, 40, 16. So drawing strategy, no problem. So here we go. My first step is obviously to take 40 off both sides, remove that constant. 16 minus 40 is negative 24. You may want a calculator to do that. I didn't need one, but if you do, that's okay, 16 minus 40. So then I'm left with this equals negative 24. Nothing new so far. Here's where it gets weird. Okay? If you watch this step carefully, it's easier for me than to figure out what x is to figure out what this is, what x's opposite is. So right now, whatever I have here, I've got 3 of this same opposite of x thing. And I know that each of those to make negative 24 must be negative 8. Negative 8 plus negative 8 plus negative 8 is negative 24. But I didn't figure out what x is yet. I figured out what the opposite of x is. So I figured out that the opposite of x is negative 8, which means that x is positive 8. Whoa, that's the weird step. So back here, and I'm going to do another one, and you'll get the hang of it, I hope, a little bit as we do a few. I didn't find x, I found the opposite of x. And I had to switch my sign to get the actual thing of x. Now, that's not as complicated in the inverse operation strategy. So if you're a drawing strategy fan like I am, that new step here at the bottom is sort of like, whoa, brand new. Nothing's really going to be new here. Inverse operation strategy is just going to carry on like usual. I know you're getting used to this. It's always the same 2 operations. So I've got times negative 3, so I'll divide by negative 3. We've got plus 40, so we'll subtract 40. And we're going to use gems in reverse to do that. And I know you're getting used to what happens where because we keep doing the same ones. So subtract the 40 first, which, by the way, is exactly what we did first here. That cancels to 0, so negative 3x equals negative 24. And again, I'm dividing by negative 3 now. I don't really have to go through all this business with the inverse operation strategy. Divide both sides by negative 3. All I have to do is make sure I don't mess this up. Negative 3 divided by negative 3 just leaves me x. Negative 24, weird, divided by negative 3. Remember, when you multiply or divide with negatives, if they're both negative, the answer is positive 8. Do another I do. You'll notice this one I said the variable's positive. X ended up positive. I'm going to do one where the variable's negative. It doesn't really change that much, but it gives you kind of a second look at this. So let's try this one. Negative 4x plus 13 equals 33. I'm not even going to try the common sense strategy. Let's jump right to visual. This is the new one. You know, the one that's kind of the big deal today. So here we go. Negative 4x. So the way I draw that, I can't draw a negative 4 of something. That's not a thing. But I can draw 4 opposite of x's on one side, and the 13, and the 33. So my first move here is to take the 13 away from both sides. And I'm going to redraw after I do that, because now I just have the variables on one side, and it's so easy to tell what they are. That'll be a 20. So here's the last weird step. I'm not able from my drawing to figure out what x is, and my goal is to figure out what x is. But what I can do is figure out what the opposite of x is. So whatever this is, I'm going to think of that as the variable. Now this is going to look really weird, because you'll notice to make 20, these have to be a positive number, even though they have an opposite sign. It looks like it should have to be a negative number, but it's not. So each of these would have to be 5, 10, 15, 20 to make 20. So what I have found out is that the opposite of x is positive 5, but I'm not trying to find the opposite of x. I'm trying to find x. So if the opposite of x is positive 5, then x is actually negative 5. Weird. But it does work. So that's the weird thing, is sometimes you don't find x, you find x's opposite, and then you just make the switch at the end to know what x is. Weird step. Inverse operation, no big deal. Nothing's really new in the inverse operation strategy in this level. So if we do this, and you'll see we'll get the same thing. So if I do this, remember the inverse of adding 13 is subtracting 13. So now we've got negative 4x equals 20. I'm going to divide both sides now by negative 4. 20 divided by negative 4, only one of these is negative, which means my answer is negative. 20 divided by 4 is 5. So x equals negative 5, just like it did here. Let's check and make sure, in case we don't believe me. Let's make sure this works. If we do, when we substitute our answer in for x, we should get that negative 4 times negative 5 plus 13 is 33. And negative 4 times negative 5 is 20 plus 13 is in fact 33. So it does work. All right, let's do 2 together. I'm going to be short on time, so you may have to pause a good bit. I only have about 3 minutes to do each one. So here we go. We're going to really focus on this visual strategy today, because this is what's new. And if you even want to make a note to yourself to focus on this, this is the new stuff. So let's set that up. 37 equals negative 5x. Maybe even draw an arrow so you remember how you draw this. You draw 5 opposite of x's. Like that. And of course the 62. So first step now would just be to get rid of the 62. I am going to pause and use a calculator to figure out 37 minus 62 real quick. Here I got negative 25 there, so when I redraw, I get negative 25 equals 5 of these negative x's. Now, from here, here's the weird part. I'm not going to find x. I'm going to find the opposite of x because that's what's in my drawing. So I'm going to circle them so that I remember they're one thing. It's not negative x, it's opposite of x. They work the same, but it's easier to think of them differently. So when I do that, if those 5 things are going to add up to negative 25, they've each got to be negative 5. So I haven't solved it yet, though. Be careful. I'm not done. All I know is that the opposite of x equals negative 5, not x. So if the opposite of x equals negative 5, then x equals positive 5. The opposite and the opposite. So that is the answer. That's the weird step, to go from here to here to here. That's what's new today when the coefficient is negative. And you even want to make a note of that's what's new too, negative coefficient. Okay, let's do the inverse operation strategy as well. This one isn't particularly different. You've just got to be good at your signs when you divide by negatives. Otherwise, no big deal. 37 equals negative 5x plus 62. So first step here, you want to be very formal about it. Remember, we're going to go reverse gems. And the variable is being multiplied by negative 5. So we're going to divide by negative 5. Also has 62 being added. So we're going to be subtracting 62 from it. So that'll be first. Subtract and add comes first. So subtract 62. Subtract 62. And again, you'll notice that's what we did over here first. We subtracted 62. It's not different. It's just different in how we notate it. So that left negative 25 on this side and negative 5x on this side. So now that's done. So now what's left to do is multiply and divide. So the inverse of multiplying by negative 5 is dividing by negative 5. Dividing by negative 5. That makes 1. And negative 25 divided by negative 5, when you multiply or divide, if both numbers are negative, the outcome is positive. And we got it. We match. Good. Let's check and be sure if, just to make double sure that we're right. So if we're right, 37 should be equal to negative 5 times the answer we got, positive 5, plus 62. If we're right, substitution. So that would mean that 37 should be equal to negative 25 plus 62. And it is. Check smiley face. Yay. All right, I am short on time, so what I'm going to do, there's another we do. You'll notice here we did one where the answer or the variable ended up positive. I need to do one where it's negative 2. I know that's a lot to put in one lesson, but this is a big old new step. So what I'm going to do is stop this video here, and I'm just going to do a short add-on video after it, part 2, to do the second we do.